it'll probably mess everything up. Can everybody still see Mars, or you can see anything else?
Yeah, it's still good.
Still see Mars. Okay.
I've not used...
probably will mess everything up. Yeah. Oh yeah, I can hear.
I can hear an echo.
Right. Okay. What I need to do now is get rid of that other window. Otherwise, we're going to hear. Oh yeah, I can hear. Right. There you go. That's muted that. Excellent. Right. So. Okay, folks. So we've got Mars on the screen. Let me get rid of that window so I can see what we're doing now. Okay, so there we are. So Mars is in the middle of the, we're not quite in the middle of the field of view. Let's just pop it up a little bit. So it's nearer the center. There you go. So the scope's not properly cooled down yet. And the reason I know that is because I've got a bit of a flare over to one side. I always get that when the scope's not quite down to temperature. And
I get that too.
You get that too, yeah.
I've not used this software, David.
Have you not? This is the one that comes with the ZWO
I realised that, yes. Yeah, perhaps I'll have a go with that because I'm always using SharpCap.
Yeah, I've used SharpCap for quite a while, and all my Venus images that I took and a lot of the Mars images that I took leading up to the opposition, they were all done on SharpCap. And then one night I tried it on ASI Studio and the images were actually much better.
Oh, right.
You know, going from straight from that one to ASI Studio, they were much better, just taking one after the other. So I've switched over to using that since.
All right. I like the ADC feature.
Yeah, the ADC feature is fantastic. I'll show that in a minute. I'm just taking a video at the moment, so I thought I'd capture one while we was going. And what I've also got, you can't see because I've got no webcam in here, is I've got a little focuser. So I've got that next to me so I can adjust the focus slightly, a little electric focuser. And I'm continually adjusting that to keep it in focus as the scope cools down, as conditions change. Yeah, so I'm continually adjusting that as we go. Who we got on? I've got a few. Yeah, join in and chat, folks, if you want to.
I think the focuser is my next thing.
Yeah, I managed to pick one up secondhand last year, so that was good. Let's zoom in a little bit. So see, it's quite wobbly.
It was quite wobbly last night.
Yeah. But now we've got a few nights now where Syrtis Major is visible on the disk quite early on now, because I've been waiting for that for ages. And
me.
This is the first real opportunity I've had to come out when it's a reasonable time of the evening to actually capture it. But yeah, the scope's not really settled down yet. And by the time it is, I reckon Syrtis Major is going to be over the limb. Can you see my cursor okay, yeah?
Yes.
Yeah, okay. Because it's rotating in that direction. This is a southern polar cap, which has shrunk enormously over the past few weeks. Let's see if I can focus it up a bit more. Well, it's getting a bit better, actually. And it's rotating in that direction. And because it rotates slightly faster than the Earth, 23 hours and something, I can't remember exactly. Tomorrow evening at the same night, Syrtis Major will be a little bit over this way. So it gets a little bit later in the same position. So really early on, if you can get out really an hour or two before this, it should be really central on the disk. So we should get some nice pictures of that. And we're meant to have some clear skies, aren't we, the next few days?
Well, I should be able to get something right through till Friday, although some of it might be from about 11 o'clock or 12 o'clock.
Right.
depending whether you check the BBC or Clear Skies or whatever you want to use.
Yeah. Yeah, so there you go. So that's the one shot color camera I'm using, obviously, to get the color image.
Good.
I'm not using a Barlow lens though.
Oh, right.
I found that when I use a Barlow lens, the light drops dramatically, and I just end up with doing such a long exposure or putting the gain up so high, just a mess. So all the images you've seen, I haven't used a Barlow at all. I know Kev uses his C11 with a 2x Barlow, so it'd be interesting to see.
I've used 3 times.
Use a 3x Barlow, do you? What make?
Explore Scientific.
Oh, okay.
And I've also got a ×4 Power Mate, but I've used that on the refractor.
Right. Okay.
But using that flip box has been a boon, getting it all lined up. It's amazing how much easier it is to set it up with. Especially if you've got a Barlow in there, it's nigh on impossible once you.
I know it is. Yeah.
And then put the Barlow in. Where's it all gone?
Yeah, exactly. Yes, this is Certis Major. This is Hellas down here as well, and I don't know any of the other features' names, so that's about it really. That's my knowledge of the surface, unless I look them up. And of course, we can't see Olympus Mons or the Tharsis volcanoes. I know those. And the Valley. Sorry,
Dave, are you videoing this image?
Not at the moment, no.
Is that where you video and then stack?
Yeah. So I use this software. I take my AVIs or SIRs, depending, and then process those using AutoStackert.
Okay.
And some of them I have processed using AstroSurface. I don't know if you've seen that one. I think I showed it to people a few weeks ago. There's one called AstroSurface, which also processes the videos and does the wavelet sharpening as well. So that's quite nice. So I sort of swap between the two and see which one gives me the best image for the data I've got.
Yeah, that's good. You got some sort of contrast in images, isn't it?
Yeah, it's not bad. I'm just having a look at the histogram there. It's I could give it a little bit more, so we'll let's just give it, because that's how I normally get my curves on the histogram, so they just nearly touch the top.
Okay.
And then you get a nice bright image, and it's not down amongst the noise. So yeah, and I've got attached to the scope on a long lead is a focuser, so I can focus that backwards and forwards, even as I'm taking my videos. But again, you know, the scope's not really settled properly yet, so that's not helping. That's slightly too much actually, so just drop it down slightly. There you go. And I'll just, there we go. So actually I should have checked to see where it was on the video. Oh, it's right near the bottom. It might be okay. We'll see.
Is the wind making it sort of shimmer?
No, there's not actually that much wind tonight. Just no, there's hardly much wind, hardly any wind tonight. So it's just
atmosphere, is it?
Atmosphere, mainly atmosphere. There might be a little bit of wind. It's not helped because I've got a big dew shield on the front of the C11, so therefore that catches the wind quite easily. That doesn't help. What I might do, I might stop this one, bring the scope a little bit up so that the planet's a bit nearer the center of the field of view. There we go. Tweak the focus again. I might actually drop down the format because there's not, you know, I think it will stay in the middle long enough. This is just a quick polar alignment. So it's not doing bad, is it?
No, you're all right.
We're doing all right. So right, okay. So what I'll do now, I'll because I've cut down the format, there's not so much data there to process when I come to process it, so the video is going to be a lot smaller. So it should hopefully be easier to process. It's still not quite focused, but we'll take something just to see what we get out of that. And I'll have a process and show you what I got out of it.
Interesting.
I'll pop it on the Padlet, and it might be rubbish, but we'll soon see. See that flaring starting to fade a bit now, so it's getting a little bit sharper. As the scope's settling down, it's getting a little bit sharper.
What's the size of your scope then, Dave?
It's a C11, so it's a 11-inch Celestron Smith Cassegrain.
All right, 11-inch. Oh yeah.
Yeah. The one that fell off the mount a few weeks ago.
Oh, right.
Probably woke the neighbours up in the early hours of the morning, but not as much as it woke me up, I can tell you.
Oh my goodness.
But it survived. It's a few dents.
Yeah.
There's a few dents. It broke the handle off the bottom of it.
Yeah.
But I've managed to get a handle to go on the dovetail now. It's a bit awkward because it's not in the right place, but at least it's a handle I can grab hold of. That's the main thing. Because getting it up and down off the mount is quite a challenge at times. It was much easier with the other handle because it was at the right angle and you could sort of lever the scope as you put it on. But because it's with the dovetail now, it has a tendency to go to one side.
Right.
But anyway. Yeah, so there we go. So that's Mars.
Okay.
Been successful there. Let's just have a look and see how many people are on YouTube. I've got 5 watching on YouTube, would you believe? And there you go. So, yeah. There we go. Anybody got any questions or anything they want to add to the commentary for folks watching? So what camera are you using on your Mars images, Roger?
It's the new ASI 462.
Okay.
The one that's quite very sensitive in the infrared end of the spectrum.
Right, okay.
So, yeah, that's been what I've been using for all my planetary at the moment.
Right, that's nicely coming into a little bit sharper now.
Yeah. It's almost a black and white image when you don't have a IR UV cut filter on there. Then it goes color after that.
Oh, does it? Right, okay.
But it's almost like a very sensitive black and white camera.
Right.
Without any filters in the front, which is really quite good because I sort of get anything out to 120 frames a second on that, which is pretty good for this sort of thing. But the file sizes are horrendous.
Oh, yeah. Have you crashed your stacking software yet?
No, it's been okay. But
really? Oh, right. I found it crashed loads of times.
Oh, right.
Yeah.
No, I've been okay.
So what I'll do, I'll grab this image and then see if we can, well, I know we can get over to the moon. So, yeah, we'll do that in a sec.
Okay.
It's all good fun, isn't it?
Yeah.
Yeah.
Yeah, I got a smaller telescope and that. Mine's only 6 inches, I'm afraid.
Right, okay.
But
as I always say to everybody, just give it a go. Because, yeah,
I could
give it a go.
I could put the camera on the back. It's got me camera, my SRI camera, but it do a video on that.
Right. Well, a friend of mine, Paul Blakesy, I don't know if you know him, from North Essex. He did some live streaming last night on YouTube with his iPhone, and he's managed to get Syrtis Major with the iPhone That's absolutely bonkers. Absolutely brilliant. You can do that with just a phone. It's just incredible, isn't it?
Yeah.
It's just incredible. Yeah. The technology in these things are fantastic. But it makes, you know, it enables everybody to get out and be able to do it, which is, you know, what it's all about, isn't it?
Yep.
Okie dokie, right, I'm going to go to the, that's the wide view. And then I'm going to send the scope over to the moon. Ah, there it is. Couldn't find it on the map. Right, here we go. The scope's on its way.
Bigger target.
Yeah, still don't mean to say it's going to be right on the middle when we get there. Well, it thinks it's there, so yeah, it's not. It's not. Right, headphones off. Back in a minute.
Ooh. Oh, right. There we go.
And as if by magic, here it comes. So you get the sense of the field of view you get with this camera and telescope. It's tiny, tiny field of view. So there's, is it going to move? It's too slow, right? Yeah, so this is Sinus Iridum. So this is the Bay of Rainbows, as they call it. Doesn't look really spectacular at the moment, but when you catch the sunlight on that, it's absolutely amazing. And because I'm using a one-shot color, let me just go and adjust that slightly. Too bright. Because I'm using a one-shot color, even in these single frames using this video, you can see the differences in color in the regolith here. So this is the iron-rich brown stuff, and this is the blue titanium-rich regolith. So you see that quite clearly, even in these raw images. It's quite incredible. I find it amazing that you can do this just from your back garden. It's incredible. If we come down to here, this is quite an interesting feature. This is crater Aristarchus. Extremely bright. It's the brightest crater on the moon. Let's see if I can just tweak that focus slightly. That's about as good as I can get it. And it's got the Schroter's Valley right next to it, which is here, but you can just about see it there, but it's, you know, quite difficult under this illumination because the sun's getting quite high in the sky as seen from there at the moment. But if you look, this is really brown. So it's really, really iron rich around here. So that's really, really brown part of the moon.
Strange, isn't it, being bright that a bit?
Yeah, it's because it's a fairly recent impact crater. So therefore it's revealed all the material underneath, which is much, much brighter, and it will fade over time. That actually leads me quite nicely down to this little feature here, which is quite nice. So just down here, there's what looks like a tadpole. So it's got a big head and the tail coming off.
Oh, right, yeah.
It's what they call a lunar swirl. And what they think that is, where the magnetic field of the moon affects the solar radiation, it doesn't get affected by the solar radiation as much as the rest of the moon. So it stays brighter because this magnetic anomaly on the surface is stopping the solar radiation from actually darkening the surface. And so this bit is staying brighter because of that effect. We go down here. This is Grimaldi. I don't know if you know some of the features, but that dark one there is Grimaldi. And this is a really good time to look at the moon, because just here, nicely visible actually, is the Eastern Sea, Mare Orientale.
Right.
And this is a huge impact feature on the surface, a huge walled plain. And you can see the Rook Mountains here that on the boundary of the huge bullseye, but we only see it very rarely when the libration of the moon swings it into view. And tonight it's not too bad actually. So there you go. There is a date this month when it's meant to be coming in a little bit further, but I can't remember when that is. So but it is on my YouTube video, the month looking ahead, and it tells you when that's going to be in position, in the best position for the year. And there's one next month, but it's not quite as good next month. Okay, so have a look at that on my YouTube video, the month of November. Let's just wander down the edge of the limb, because this is the boring part of the limb, because this is where the sun is hitting the surface quite at a high angle. So we're not getting many shadows. Now we're going to get to the really interesting bit, where the sun's setting on the moon. So this bright crater here, that's Tycho. And again, because it's a fairly fresh crater, it's not as bright as Aristarchus, but you can see these rays emanating from it, where the material that splashed out from the impact that caused the crater has thrown up all this lighter material onto the surface of the moon. And of course that will darken over time for the solar radiation, but it's still relatively fresh as far as the darkening is concerned, so it still looks very bright. Let's carry on over here where it gets a little bit more exciting. So this is where the sun's setting on these craters. They look absolutely marvelous. And this one here just coming into view, that's Janssen. It's almost hexagonal shape rather than round.
It's almost like a paw print there, David.
It's almost like a paw print. Yeah, it is. Yeah, so you can see this rill going across it as well. There's a nice rill. And actually, I didn't realise until I pointed out to people at the club that there's quite a number of craters on the moon that are actually hexagonal rather than circular. I didn't realise that until I'd pointed that one out to somebody.
Well, the angle it's coming in you know, impact wherever it's coming.
No, I'm not sure what causes it, but yeah. So as we come up, I don't know
the
names.
It's going to make it more of a sort of an elongated sort of crater, isn't it?
Well, if we come up to, if they're still visible, I'm not sure if they're still visible when we get up here. No, I think it's too late for them. But if you look at Messier crater, there's Messier and Messier A. Oh, they're just visible. Look, right on the edge here. Let's up the exposure. We might be able to see them a bit closer. There's two craters really close together. And they're right on the edge. Yeah. And that's where they think something that hit the moon hit at an angle. And you can see these rays. There's two rays. You might just be able to see those. There's two rays, bright rays coming out, and it looks like a comet. So the fact they've named it after Messier is quite nice, really. Right, let's carry wandering up. Quite dramatic, isn't it, really? But, you know, when you look at the moon, this is evidence of what happened to the Earth. This all happened to the Earth, but our weather and plate tectonics, volcanism has all obliterated most of it from the surface. Whereas on the moon, because there's none of that, we see it as it is. Here we come round. Back towards the northern part of the moon again, and then we'll travel down the centre of it. See, the old seeing's a bit wibbly wobbly, isn't it? Not going to do any serious moon imaging tonight, I don't think. Let's take the brightness down a bit.
Well, it looks like you got better seeing than I've got. It's still very misty from here, looking at the moon out the window.
Well, sometimes mist helps. I've found before. I've gone out on a night where I haven't done it for ages and it's been a bit misty, and I've got some really good images through the mist.
I'll give it a go then. Give it a
go. Go on. You never know till you try. Oh, that's quite a nice pair. I'm not quite sure what they're called. I can't remember. Anybody? I haven't got my spotter's guide to craters with me, and I haven't got my torch to have a look at my map. So we'll just have to forget what they are. And then coming down, of course, just here.
Bright one. Bright.
Yeah, that's.
There's two bright ones.
Bright one there. Yeah. Coming down here. So this is. There we go. So this is where Apollo 11 landed, just about here somewhere. And it's close to these two craters, Sabine and Ritter, here. Yeah, so Apollo 11 landed about there somewhere.
Those two craters, David, were Atlas and Hercules.
Oh, the ones at the top, yeah. Yeah, let's go back to them then, shall we? Let's put back up.
I got my little...
Not those, it's a bit further up, wasn't it? Wrong way. There we go.
Yeah.
Let's just see if we can focus that a little bit better.
And the ones below it is Cepheus and Franklin.
These two here?
Yes.
Ah, okay. And then you've got this one, which has got a little sort of, it's got the wall, but it's also got this little raised bit in it as well below that.
Poseidonus, yes.
Posidonius. Posidonius. Yeah, okay. Yeah, good. So I know them, but I just can't remember what their names are until I get to them. Having been many a time. As you see, the terminator part where the sun's coming in at an angle is creating lots of shadows. You see a shadow here, but if you imagine on the surface, all the little irregular pebbles and grains of sand are all creating their own little shadows. So when we look at the moon with our camera, you can see that this side is much darker than if we go into the moon.
I think that's Tarantuus.
Tarantuus,
yes.
Yes. So there you can see, zoomed out, you can see that tail coming out of the comet quite nicely.
Right, oh yeah.
Now, yeah. Let's try taking that. See if we can get a little bit more contrast with it. Yeah, is that a little bit more contrast for you? Yeah, there you go. So there's a good one. Let's but see just how much brighter it gets as you come in, and the sun's higher in the sky for that part of the moon. So we have to take the exposure down so we can see it in a bit more detail.
Quite good.
Okay, let's see how many we got in. 3 watching now.
If you stack those together, it'd be quite good for when you get quite a good image out of that.
Yeah. It's a little bit wobbly, but it's not too bad.
Too bad at all.
And I can't remember what this is called. Roger, you got your map here?
Which one?
This.
Oh, that.
This escarpment, isn't it?
I haven't got anything labelled on here. On that.
Have you not? Right. Okay.
Roops Altai. No.
Roops. No, it's not Roops Altai, is it?
Well, I've got it written across.
I can't. Oh, right. It must be then. Yeah. Okay. I can't remember. I must admit, I've only really got to grips with the moon in the last 4 or 5 years, I think, because most of the time I ignored it because it was just the thing that used to spoil all my big sky stuff.
Moon out again.
Yeah. So let's come round the bottom of the moon. But you can see just how wobbly the edge of the moon is. And of course, when you get the moon moving through the sky, if it goes past the star, it can disappear behind a mountain and come out in a valley. So stars, if it moves across the star in a certain way, it can flash on and off a number of times as it disappears behind peaks, especially if it goes behind a part of the moon that's not actually lit by the sun. And they look really dramatic when they do that. And they're the same things that cause Bailey's beads during an eclipse, of course.
And I would also be able to use calculations for the height of the structures there.
Yep. Yeah, I would show you Clavius, but you know, the famous Clavius where they discovered all this water,
yes,
locked up in the soil, but it's not looking very good tonight because obviously it's the sunlight is almost overhead.
Right midday there.
Yeah, it's not quite because you can still see a little bit of shadow in the craterlets in it. So this is Clavius here.
Right. Yeah.
Going back out again and head north a little bit, show a couple more features. Apart from the bright spots, it all looks very featureless. So you have trouble well, we know what this one is anyway. That's Copernicus.
Yeah.
Yeah, so you can hardly see Copernicus because the sun's almost overhead at that particular moment. So, yeah, and if you come in this direction, this one here is Eratosthenes, and this is what do they call them now? Is it not the Apennines, is it? Because it's got Eratosthenes right on the end of it, and it's like an arm coming out. And of course, up here is where Apollo 15 landed.
Apennine Mountains.
The Apennine Mountains, yeah. And Hadley Rille is up here where the Apollo 15 landed.
Too bright a moon moment for the
yeah, you're not going to see any of Hadley Rille or anything because there's no shadow to pick it out.
I suppose sort of the best phase for the moon is different objects at sort of different times, isn't it?
Yeah, when it's close to the terminator. So when you get the shadows like that, that's you know, that's when you want to look at the moon, because when you look at it when it's full or when the sunlight's overhead at the object, you're not going to see it in any great detail at all because there's no shadows to pick it out. So this is a quite distinct crater here. This is Plato. And this is the Alpine Valley. So, yeah, so that's a big valley in the mountains. And right in the bottom of it, there's a little rill. So if you can get an image of that, that's a really good night if you can capture that rill in the bottom of the Alpine Valley. That one, is that Cassini, isn't it?
Probably. Oh, yes, sorry.
Yeah, and this one here, I can't remember. I should know.
Well, that's just above Archimedes. This
Archimedes, that's it. Yeah, Eureka! I found it.
Sinus Lunasus. And you got Aristarchus and Autolysus.
Yeah. But of course, any of the craters down here are hopeless because, you know, sunlight's virtually overhead, so you can't see them. Hardly at all. So here's Ptolemy or Ptolemaeus. And I can't remember what the other one is underneath it. But you can see the darker patches in the floor.
Alphonsus and Arzachel.
Arzachel.
Arzachel and Alphonsus.
Yeah, okay. And just over here, we should have the straight wall, but I'm having trouble identifying where it is. Rubbish. A different phase, I'd recognise it, but at the moment I'm having trouble getting my bearings where it is. Hold on. Usually it jumps out at you, but not under this illumination. It's not. I'm too far north now.
Okay, thank you, Dave. I'll leave you.
That's all right.
Okay,
I'm
thanks.
gonna call it a night in a minute. So yeah, it's been good fun.
Thank you. I'll see you next Tuesday. Not Tuesday.
No, 2 weeks Tuesday.
2 weeks
Couple
Tuesday.
of weeks time. Yeah.
Yeah.
Okay then. Take care.
You. Cheers,
Bye. Bye.
See you, Colin.
Cheers, Ian. Cheers, Roger.
Right, there you go. If anybody got any questions, I'll have a look in the YouTube, see if anyone's put any down. What's the scene like? Oh, hi, Steve. Yeah, it's a bit bumpy. Oh, Lorman Lockyer Observatory. Hiya. And great. Yeah, I understand mist means a more stable atmosphere. See someone else backing me up there, Roger.
Okay.
So there you go.
Right.
But it's not just me who's seen that. So excellent.
Well, Damien Peach says if it's frosty outside, then it's absolutely perfect for still atmosphere.
Yeah, I know, but it's not perfect for us, is it? Let's face it.
Well, no, but can't win.
I know you can't win. No, we're never satisfied.
No.
Yeah. No, I failed to identify where the straight wall is, I'm afraid.
The moon's getting more misty here.
Is it? Let's have a look out. No, it's still clear as a bell here.
Oh,
so what I'll do, I'll go over to the exciting side, over near the terminator where the sun's setting on the moon, just to have a little tour around the edge of there for folks. So we'll have a slow tour around. It's a bit too slow, but there you go. Look at those craters, absolutely amazing. How people can't be interested, I don't know, but there you go. It's actually seeing it's getting pretty good now. What I might do, I might go a sneaky peek back at Mars in a minute, as the seeing looks like it's settling down. I should know more of these features off by heart, but I don't, I'm afraid. So back to Messier and Messier A. That's nice. I like that. Just poking in the poking in there. And let's up a little bit so we can that bit brighter. Well, look at how that shadow's flooding the valley in there. Look. Wonderful stuff. There you go. Right, what I'm going to do, I'm going to go and get it set up on Mars. Won't be a second.
Ooh. Oh, there it is.
There it is, the pesky thing. Right. Too much?
Ooh.
Yeah, let's yeah, just tweak the focus again.
Ooh.
It's all a balancing act.
Yeah.
There you go. So Syrtis Major is making its way over to the right-hand side of the disc. Pop it up there a bit. There we go. Let's see if we can catch something. Just tweak that focus again a little bit. That's a bit better. Oh, it's drifting horribly now. Hold on. Let's get it back in the center. Start again. It was holding its position quite well earlier, but it now seems to be wanting to nod down slightly. Never mind. How far we got with the video? So, 37%. Nah, it's not going to do it, is it? I'm going to have to nudge it up a bit. No, that's misbehaving far too badly. Hold on a sec. Get it back again.
Oh.
It's all right, I stopped. Just tweak the focus. A bit brighter. Yeah, that's really drifting horribly now compared to what it was earlier. Why does it change? Why does it change? But there you go. All part of the fun. If it was easy, everyone would be doing it, wouldn't they? Right, go.
Because my camera's quite a high frame rate, I only do about a million videos. I usually get about 5,000 frames or so.
Right, okay, yeah.
It's a balancing act of file size versus...
It is, yeah, it is. Yeah. It's still wanting to go down. Little blighter.
Yeah. It's your polar alignment.
Well, it was perfect earlier, wasn't it?
It's not fighting against the balance of your scope, is it?
No, it shouldn't have changed that much, I wouldn't have thought, but there you go. He gave up and watched us instead. Thanks, Stephen. Oh, it's nearly going. Still amazes me when you process these, what you can get out of them.
Incredible, really.
It is. Right, I'm going to move that up.
Right.
I'll take a shorter one this time, so I don't have to fight it quite as much. Was it nearly 10 o'clock? That's good.
It certainly made a hell of a difference with the clocks going back.
It certainly has. Why's the screen frozen? That looks interesting. Yeah, look, blue circle. Oh no, it's still going.
Ooh,
how strange. Ah. Whoops. All of a sudden, that scene looks atrocious. Let's try adjusting the focus again. Get it any better? Oh, that's a little bit better. Right, let's have a try. Well, there you go.
I mean, when I'm doing it myself, I get very brief glimpses of superb clarity on the features of Mars.
Yeah, that's what you'd expect.
But it's just momentarily.
Yeah, yeah. Typical observing conditions, unfortunately. Of course, Mars being so small, even though it's at its best, or just past its best, it's still quite small. When you consider how big it is compared to some of those craters we were looking at, you know, it's not as big as a lot of those craters we were actually looking at a little while ago. So,
no, you probably fit Mars in Clavius.
You certainly could, yeah. And so if you imagine if you were trying to image one of those craters in really great detail, that's what you're trying to do with Mars.
Yeah.
You're just concentrating on a very small area and trying to get the best of it. There you go, folks. Anyway, eventually, after all the technical issues setting up, we managed it.
Hey.
Excellent. Right, well, thanks for joining in.
Okay.
Thanks to everybody on YouTube as well. Oh, Dave, Stephen, yes, question, what scope am I using? No, I'm not using a Barlow, but it's my Celestron C11 that I'm using to take the images, and I've just used the region of interest on the object so that it looks zoomed in, really. I found that when I used the Barlow, the light levels went down so much that I couldn't get a good image out of it. Okay.
Well, if you use a 2 times Barlow, you're using a quarter of the light. If you use a 3 times Barlow, you're losing 8 times as much light.
I know, it's bonkers, isn't it? So yeah, it's just drifted out of the field of view now, but there you go. You have to get it back.
Oh, Mars rise.
There you go. Yeah. So I'll just show you this ADC. So I've got an ADC, which is an atmospheric dispersion corrector in between the camera and the scope. And what that does, that stops atmospheric dispersion. So it splits the colors. And once you've got it in set correctly, now I didn't actually check it when we went back to Mars, so it might actually be out now because you have to keep adjusting it as you go. But within the ZWO software, there's an ADC tuning button. And if you press that, you can see these 2 circles, a blue and red circle. And as you adjust the ADC, you can see them superimposed on top of one another. They're not far off now, so I'm going to leave it as is. I'm not going to fiddle and then just. Yeah. So we're not losing any definition due to atmospheric dispersion. So what we are seeing is just atmospheric disturbance, and the scope perhaps not quite as cooled down as it should be. Okay, right, folks. Well, thanks for joining us.
Thank you, David.
And I'll see you all again.
Yeah.
Yeah. See you. Take care.
Bye, Dave.
Bye.